Welcome to Computer Science Play Tutorials. Today we are going to discuss about stack data structure. It is linear data structure. Here linear data structure means it stores data in a ordered format or sequentially. Ordered format or sequential format. It follows LIFO structure. Last in, first out structure. To understand this point clearly, first we have to take an example. For example, this is a stack. These are elements, and we inserted these element into the stack and another element 40. Now when we want to retrieve data from the stack, for example, we want to retrieve element 20 from the stack. We cannot retrieve the 20 directly from the stack. Before retrieving 20, we have to retrieve 40 first, and then 30, and then 20. First, we have retrieved 40. Then we have retrieved 30. Afterwards, we have retrieved 20. Now, in the stack, there is only this. It contains only one element, that is 10, because we retrieved all these elements. When we want to retrieve an element from the stack, we have to follow this order: last in, first out. The element which gets inserted first into the stack is retrieved last from the stack, or the element which gets inserted last into the stack is retrieved first from the stack. For example, we have a section of plates arranged in this manner: plate 1, plate 2, plate 3, plate 4. If we want to retrieve plate 3, we want to remove plate 1 first and plate 2, then we have to retrieve plate 3, because it follows last in, first out structure. If we directly retrieve 3 from the stack, the entire plate gets scattered and this ordered format becomes empty. That is about last in, first out structure. Note these 2 points. And now I want to explain some terminologies related to stack so that you will clearly understand when I explain stacks working terminologies. First, top. Top is the pointer pointing the points top element of the stack. I will give an example. This is a stack. It contains some elements. Top points this element because this is the topest element of the stack. For example, 3 gets removed or deleted from the stack. Then top decrements, and top points 2. So that is about top. And next terminology is push. Simply, push means operation that inserts element into stack. And pop. Pop means operation that removes or deletes an element from the stack. And next concept is empty. This operation checks whether the stack is empty or not. Whether the stack is empty or not. It retrieves true or false as output. True means the stack is empty. False means stack is not empty. It contains some elements. Fifth operation is full. Checks whether stack is full. Here full means when we create a stack, we define some size to it. For example, define size is 5. This operation checks whether stack already contains 5 elements. There is no place for another new element. Here index starts from 0, 2, 3, 4. So stack is full when top is equal to 4. In this context, we define that size is equal to 5. Then stack is full when top is equal to 4 because index starts from 0. So this operation checks whether the stack is full. So this operation retrieves true or false as output. True means the stack is full. That means top is equal to size minus 1. Here size is 5 and the condition is size minus 1 means 4. It retrieves false when the stack is not full. These are the terminologies of the stack. Now I will explain working of stack with an example. Note all these points in your notes so that you can easily remember all these points in your exam. Now let's see the working of stack. For example, these are the elements. These are the elements. We need to insert these elements into the stack data structure. First, we have to define size. Here, size is equal to size of the stack is equal to 5. Now, empty stack gets created. This stack is empty. Now, initial condition. Top is equal to minus 1. Top points to minus 1 because stack is empty. And second step, we have to insert 101 into the stack. That means we have to perform push operation with element 101. Push 101 into the stack. When we perform push operation, top gets incremented. Previous top is minus 1. Now top gets incremented. Minus 1 plus 1. That is 0. Top becomes 0. This is the condition. Okay, top is equal to 0. This index is 0. Next step. We have to insert 202 into the stack. First, before inserting, we have to check whether the stack is empty or full. Here stack is empty. That's why we have inserted 101 into the stack. Now we have to check whether the stack is empty. Stack empty condition is empty condition is top is equal to -1, because see here when the stack is empty, top is equal to -1. Here top becomes 0. Top is equal to -1 condition fails because top is equal to 0. Therefore we can insert 202 onto the stack. Here also we have to check whether the stack is empty. I have explained in this step. Here come to previous step. Is empty condition. Top is equal to -1. Yes. Condition success. Then we have to insert 101. Everywhere we have to check this step, but manually it is not required because we are not doing any programming here. After that, in the next concept, when I will explain the stack programming, then I will explain about is empty, is full conditions clearly. For now, just see insertion and removing operations on the stack. Now we have to insert 202 onto the stack. Therefore, operation is push of 202. Here already 101 is there, 0. We have inserted 202. Now push operation performed here. Therefore, top have to be incremented. Here in previous step top is equal to 0 and top gets incremented. That means 0 plus 1. Then top becomes 1 here. In same process we have to insert 302, 402 and 502. We have to insert 302. Therefore, push of 302. 101, 202, and 302. And top gets incremented. Previously top is 1. Now top becomes 2. Like that we have to perform push operation on the stack. Now I will explain pop operation. After performing all the push operations, stack become like that, like this. Now we have to perform pop operation. We have to remove 502 from the stack. Then operation is pop of 502. This is the element, we have to give index here. Now stack becomes like this. In this step top is equal to 4. When we perform pop operation, top gets decremented. That means here top is equal to 4. Initially top is equal to 4. Decrement means 4 minus 1, that is 3. Top becomes 3. Here top points 3. Likewise, we have to perform pop operation. Now peak. Peak gets top element from the stack without deleting it. Pop deletes the element and removes from it and gets the element. For example, pop of 5, if we perform pop of 502 from the stack, it gets 502 as output and it deletes 502 from the stack. When we perform peak, it gets only 402 from the stack. It does not delete 402 from the stack. That is the peak operation. Now I will explain is empty condition. First stack. Here we are using top pointer to point the elements on the stack. Is empty means top equal to minus 1. When top is equal to minus 1, then stack is empty. Is full condition. When top is equal to size minus 1. That means, for example, for these elements size is 5 and stack index is like this: 0, 1, 2, 3, 4. This is size minus 1. So stack is full. Is full condition is top is equal to size minus 1. Is empty condition is top is equal to minus 1. These are the entire concepts about stack. I covered almost all the concepts of the stack. I will upload the programming video in later classes. Thank you for watching my video. Please like, guys. If you like my video, then my videos gets recommended to more students who are in necessity. Please share to some students who requires these concepts. Please subscribe my channel, guys. Thank you. Please support.